funky.
Hi, welcome back to the channel, and I hope you're having a good day. This is part 2 to review for unit, I don't know. So yeah, we're gonna go over this lab quiz, basically on lenses and stuff. So, these are basically just like things that you should know. So basically just like things you should write down and you should know and stuff like that. So, another name for a convex lens is converging lens. Another name for concave lens would be diverging lens. You should know that because they switch the words interchange. Okay, you know what I'm trying to say. According to table 2, when does a convex lens produce a virtual image? When the object is between F and the lens. And I'm pretty positive that that is the only time it will ever produce a virtual image, I think. Don't quote me on that, but I'm pretty sure it is. So yeah, when the object is between F and your lens, the convex lens is going to produce a virtual image, which is going to be upright and something like that. It's going to be upright and something else on the same side, I think. Okay, number 3, according to table 2, when does a convex lens produce a real image? So basically, like I was saying, when object is between 2F and F, beyond 2F and at 2F, and this one is between F and the lens. So you see how all of these are other scenarios where it produces a real image, and then that is just the one of it that produces virtual image. So yeah, just know that. According to table 1 and 2, when does a convex lens produce an image that is inverted but equal in height to the object? So it's going to be a real image because it's inverted, but it's going to be the same height as it, and that is when it's at 2F. According to table, what position will no image appear? That would be an F. It's going to be blurry and it's going to go into the state called infinite. So basically, you just can't see it, I guess. So yeah, at F. According to table 2, real images are always inverted. Real images and virtual would be contradicting one another. Upright, no, it has to be upside down, which is what we call inverted. And reduced, they're not always reduced because we just talked about a scenario where it's a real image, but it's also the same height, so it's not always. What is another name? I already told you guys, divergent lens. When does a concave lens produce a virtual image? At any point, because all a concave lens produces is virtual images, because the little arrows that come out of it, are they called waves? The things that bend into the lens? Yes, they're called waves. It's basically like it's basically like refraction, right? Like it goes and then it goes into the medium, which is the mirror, and then it changes its direction. For concave, it's going to spread out and like instead of the way convex is. So all you're gonna get is virtual images. I rambled, but I'm trying to explain it as best as I can. How does the image of a concave lens always appear? It's always going to be virtual and upright because it's not a real image. Where is the image of a concave lens located with respect to the lens and the object? It's going to be on the same side of the lens as the object. Yes. According to table 3, when the object distance is decreased, what happens to the height of the image and the image distance? So the image height is going to decrease and the distance of the image is going to decrease. I was very confused on this one, so yeah, I guess. In general, as the object distance is decreased, your height of the image is going to increase. Again, I got it wrong for a reason. I still don't understand. But that is the end of this one, and I hope you enjoyed and learned something new. I will see you in part 3. Goodbye. Okay, here are some of my notes for the equations of this little unit. So, yeah, have at it. Yes, goodbye now.